Okay, so in this lecture, we're going to talk about absolute convergence, ratio, and root test. Now, these two tests will prove useful in determining radius of convergence for different power series that we meet in this course. Okay, so we'll start with a definition. The series sum an is called absolutely convergent if the series some absolute value an converges. This is the definition of absolutely convergent. Okay, so you look at the series, and then you look at the corresponding series where you take the absolute values of all the ANs instead. So, remark, if the terms AN are positive, then absolute convergence is the same thing as convergence. And that's because ANs, if they're positive, they're equal to their own absolute value. Okay, we'll have a look at some examples. Are the following series absolutely convergent? Okay, so you're going to look at the series, then you're going to look at the corresponding series where you take the absolute values of the terms, and you're going to see, does this new series converge? So are the following series absolutely convergent? First example, sum of -1 to the n over 2 to the n, from n equals 0 to infinity. Second example, sum from n equals 1 to infinity, -1 to the n plus 1 over n. Okay, so at this point in the video, I think it'd be best if you just pause it and try to see for yourself if you can figure out, are the following series absolutely convergent, A and B? Okay, so hopefully you took some time to attempt the questions. I'm going to run through the solutions now. A, we had the sum, and we want to look at the absolute value now because we're asked is it absolutely convergent of the absolute value of -1 to the n over 2 to the n from 0 to infinity. So if we take the absolute value of -1, we get just 1. So this is a half to the n from 0 to infinity. And this is equal to 1 over 1 minus a half. Now, how do I know this? This is by the formula for a geometric series, which we've seen before. So by formula for geometric series, which I'll remind you is sum r to the n equals 0 to infinity, equals 1 over 1 minus r. And this is only valid for absolute value of r less than 1. And in our case, r is a half, so this formula is valid. So we have 1 over a half, which is equal to 2. Now you might have seen a different version of the formula for a geometric series where you had an a, but this formula is just a version where a is 1. Okay? So hence, sum n equals 0 to infinity -1 to the n over 2 to the n is absolutely convergent. Okay, second example. We had sum. Now we want to look at absolute value -1 to the n plus 1 over n. And n went from 1 to infinity. So as with the last case, when you take the absolute value of -1 to any power, you just get 1. So this is going to be sum 1 over n. This should look familiar. It is the harmonic series. And we know from the previous lecture that this diverges. Hence, sum minus 1 to the n plus 1 over n equals 1 to infinity is not absolutely convergent. Okay, so we've seen an example of a series which is absolutely convergent, and it's an example of a series which is not absolutely convergent. Again, absolute convergence is if you take the sum, instead of the ANs, you take the sum of the absolute values of the ANs, and you check, does this new series converge?